Hi everyone, welcome to the fourth meeting of Cryptography Club. Today we're going to review last time's code for a short message encryption, learn more Python stuff on W3 schools, from Booleans to functions, and create a new program for a short message encryption but with a larger offset. First, let's review last time's code. This is what we used last time for encrypting a short message. The offset was 10, so we first made an empty string and a string with our message in it. Then we used a for loop to turn the character into its code point, add the offset onto it, and turn it into a new character to encrypt it, and then making a new string variable and putting the new character into the string each time. And then lastly, we printed the message that we wanted to encrypt and the encrypted message, which is the ciphertext. For today's W3 schools, we will look at all of the ones with the red check marks beside it. The ones with a black circle beside it are the ones that we will look at in the future, but not today. The crossed out ones means that we won't ever look at it unless we actually need to, but you can also learn about it in your free time if you're interested. So we're going to look at Booleans, operators, if-else, for loops, and functions. Starting with Booleans. Booleans represent one of two values, either true or false. In programming, you often need to know if an expression is true or false. You can evaluate any expression in Python and get one of two answers, true or false. When you compare two values, the expression is evaluated and Python returns the Boolean answer. So here, we want to see if 10 is bigger than 9. We know that 10 is bigger than 9, so this will print true. This second one will print false, and the third one will also be false. When you run a condition in an if statement, Python returns true or false. Here it says print a message based on whether the condition is true or false. 200 is put into A, 33 is put into B, and it says if B is larger than A, then print B is greater than A. Otherwise, print B is not greater than A. 200 is bigger than 33, so it will print B is not greater than A. Evaluate values and variables. The bool function allows you to evaluate any value to give you true or false in return. Here, if we want to see if the string of hello is true or false, we can print the Boolean value of it. Here, hello, which is a string, and 15, which is an integer, will both be true. We can evaluate two variables by assigning hello to x and 15 to y and printing the Boolean values of x and y. They're both still true. Most values are true. Almost any value is evaluated to true if it has some sort of content. Any string is true except empty strings. Any number is true except 0. Any list, tuple, set, and dictionary are true except empty ones. So these will all be true. The string of ABC, the number 123, and the list with apple, cherry, and banana in it. Some values are false. In fact, there are not many values that evaluate to false, except empty values, such as the empty list, tuples, dictionaries, and strings. The number 0 and the value none. And of course, the value false evaluates to false. These are basically all of the things that you can possibly find that will return false. So false, none, 0, empty string, empty tuple, empty list, and empty dictionary. One more value or object in this case evaluates to false, and that is if you have an object that is made from a class with a len function that returns 0 or false. We don't need to understand this right now, just remember that these are false. Functions can return a Boolean. You can create functions that returns a Boolean value. So here, we defined a function called myFunction and it returns true. When we call on the function, it will be true, and if we print it, it will print true. You can execute code based on the Boolean answer of a function. For example, print yes if the function returns true, otherwise print no. Here the function returns true, so this basically says if true, print yes, else print no. We know that the function is true, so it will definitely print yes. If we change the function into return false, then it will print no. Like that. Python also has many built-in functions that return a Boolean value, like the isInstance function, which can be used to determine if an object is of a certain data type. Here, check if an object is an integer or not. So we assign 200 to the variable x, and we print isInstance x integer. So we want to see if x is an integer. So this will return either true or false, and then we will print that. Here x is an integer, so it will print true. Now let's do some of the exercises. The statement below would print a Boolean value, which one? See if 10 is bigger than 9, this would be true. "10 doesn't equal 9, so this is false. 10 isn't smaller than 9 either, so this is also false. So we want to see if the string ABC is true or not. Strings are always true unless it's an empty string, so this is true. 0 returns false. Now let's look at Python operators. Operators are used to perform operations on variables and values. In the example below, we use the plus operator to add together two values. So we can add together two integers. 10 plus 5 is 15. Python divides the operators in the following groups: arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, and membership operators. We don't need to worry about bitwise operators right now. So in this example, it was an arithmetic operator, so basically doing math. These are all the arithmetic operators. We can do addition, subtraction, multiplication, division. Modulus is dividing it, but seeing the remainder. So here, this would be 5 divided by 2 and see the remainder of that. So it would be 1. If we change it to 3, if we change y to 3, then the modulus would be 2. Because 5 divided by 3 equals 1, and it has a remainder of 2. Exponentation is x to the power of y. Floor division is dividing it and rounding it down to the nearest whole number. So here 15 divided by 2 is 7 point something, and it rounded it down to 7. We can also try turning y into 3. It would be 5, because 15 divided by 3 is 5. If we turn it to 4, it would be 3 point something, and then it rounded down to 3. Assignment operators are used to assign values to variables. Here, we assign 5 to x. If we put the plus sign and the equal sign together, it is the same as x plus 3 assigned to x. So here x is 5, and then we make x have a new value in it, which is x plus 3. So the new value would be 8. We can also try changing the 3 to a 4. Now x is 5 plus 4, which is 9. And it is the same for x equals x minus 3, or x equals x times 3, and so on. You don't need to worry about these right now, because they're related to the bitwise stuff. So for this one, we assign x to the power of 3 to x, and change the x to the power of 3. Comparison operators. We can compare two values, two equal signs, to see if the two values are equal or not, and an exclamation mark before the equal sign to see if they're not equal or not, and the greater than, less than, greater than or equal to, less than or equal to. We can try one of the options. So here 5 is in x, 3 is in y, and then we print x is less than or equal to y. So this returns a Boolean value. Because x is 5 and y is 3, x is not less than or equal to y, so it's false. Logical operators are used to combine conditional statements. The AND operator returns true if both statements are true. So for example, if x is less than 5 and also less than 10, then it will return true. If x is only less than 5 but not less than 10, then it will return false. Here x is 5, and then we see if x is bigger than 3 and x is smaller than 10. So we're seeing if x is in between 3 and 10. 5 is in between 3 and 10, so it is true. If we turn it to a 2, then it should be false. Because x is no longer bigger than 3. The OR operator returns true if one of those statements is true. So if x is smaller than 5 or smaller than 4, then it will be true. 5, we want to see if 5 is greater than 3 or smaller than 4. It's greater than 3, so it's true. The NOT operator reverses the result. It returns false if the result is true. So here x is 5, and then we want to see if x is not greater than 3 and not less than 10. So we want to see if x is not in between 3 and 10. X is in between 3 and 10 right now, so it is false, because it used to be true in here, but then we put a not in it, so it's false now. Identity operators. Identity operators are used to compare the objects, not if they are equal, but if they are actually the same object with the same memory location. Is operator. It returns true if both variables are the same object. So if x is the exact same thing as y. So if these two variables are the same thing. So here, x is a list with apple and banana in it, y is another list with apple and banana in it, and z is x. We want to see if x and z are the same thing. It is, because we assigned x to z, and it is definitely the same thing. Print x is y. We want to see if x is the same thing as y. It returns false here, because even though the list contains the same thing, they are not the same list, and there are two different lists. We want to see if x equals y. The two equal sign means if they contain the same thing or not, and this returns true because the lists are the same. They both have apple and banana in it. They are the same, but they are not the same list. Membership operators. Membership operators are used to test if a sequence is present in an object. The in operator returns true if a sequence with the specified value is present in the object. We want to see if x is in y. Here, x is a list with apple and banana in it, and we want to see if the string banana is in x. It's true because banana is in it. Not in returns true if a sequence with the specified value is not present in the object. Here, pineapple is not in the list apple and banana, so it returns true. We can ignore the bitwise operators because we don't need to use it right now. Multiply 10 with 5 and print the result. Division is the slash. Use the correct membership operator to check if apple is present in the fruits object. This is in. Use the correct comparison operator to check if 5 is not equal to 10. We would use an exclamation mark and the equal sign. Use the correct logical operator to check if at least one of two statements is true. It would be or. Okay, now we go to if-else. Python conditions and if statements. Python supports the usual logical conditions for mathematics: equals, not equals, less than or equal to, greater than or equal to. We talked about that in the operators. These conditions can be used in several ways, most commonly in if statements and loops. An if statement is written by using the if keyword. Here, a is 33, b is 200. If b is greater than a, then print b is greater than a. Here, 200 is greater than 33, so this will be printed. In this example, we use two variables, a and b, which are used as part of the if statement to test whether b is greater than a. As a is 33 and b is 200, we know that 200 is greater than 33, and so we print to screen that b is greater than a. Python relies on indentation, white space at the beginning of a line, to define scope in the code. Other programming languages often use curly brackets for this purpose. Here, they have an if statement, but they didn't indent it to show that the print is part of the if statement, so this will raise an error. If we indent it by putting a few spaces, then it will work as usual. The elif keyword in Python is Python's way of saying, if the previous conditions were not true, then try this condition. Here, it first tries if b is greater than a. Here, b and a are the same, so it will not run this part of the code. It will go to elif, so if the if statement isn't true, then it will try this one. So it then sees if a is the same as b. Here, this is true, so it prints a and b are equal. In this example, a is equal to b, so the first condition is not true, but the elif condition is true, so we print to screen that a and b are equal. The else keyword catches anything which isn't caught by the preceding conditions. So first it sees if b is greater than a, then sees if a and b are equal. If both of these are not true, then it jumps directly to else and prints a is greater than b. Here, 200 is greater than 33, so it will skip this one and just print a is greater than b. You can also have an else without the elif. So as long as this is not true, it will just jump to else and print b is not greater than a. So 33 is not greater than 200, so it doesn't print this. and it goes to the else and prints B is not greater than A. There is a way to make the if statement all appear in one line, but at the moment we don't need to use it because it makes it a bit more hard to understand. It can make the code shorter, so if you are already very familiar with it, you can also use the shorthanded ifs to make the if statement onto one line. But right now you don't need to worry about it. You can also make a shorthanded if-else all on the same line. The AND keyword is a logical operator and is used to combine conditional statements. Test if A is greater than B and if C is greater than A. Here, A is 200, B is 33, and C is 500. We want to see if A is greater than B and if C is greater than A. So yes, 200 is greater than 33, and 500 is greater than 33. So both of the conditions are true, and this string will be printed. The OR keyword is a logical operator and is used to combine conditional statements. It tests if A is greater than B or if A is greater than C. So as long as one of these conditions are true, then this will be printed. A is 200, B is 500, so this first part isn't true, but 200 is greater, 200, oh wait, no, here. B is 33, so 200 is greater than 33, but over here 200 isn't greater than 500, so this one is false. But we use a OR here, so if one of these are true, then this will be printed. And this is true, so we print at least one of the conditions is true. Nested if. You can have if statements inside of if statements. This is called nested if statements. So if x is greater than 10, we know it is because it's 41, then we print above 10. And we also go into the next if statement, which sees if x is greater than 20, which is still true, then we print and also above 20. If it isn't above 20, then it doesn't print that and prints but not above 20. Here both of the if statements are true, so it will print above 10 and also above 20. If we change the x into 16, then it will print above 10 and then but not above 20. The pass statement. If statements cannot be empty, but if you for some reason have an if statement with no content, put in the pass statement to avoid getting error. So if B is greater than A, then pass. It doesn't do anything, but if you don't put the pass, it will have an error. Print hello world if A is greater than B. If A is greater than B, print hello world. If A is not equal to B, if A is equal to B, print yes, otherwise print no. So otherwise is else. Print 1 if A is equal to B, print 2 if A is greater than B, otherwise print 3. So here, if A equals B, print 1, elif A is greater than B, print 2, otherwise print 3, else. Print hello if A is equal to B and C is equal to D. So both of them need to be true, so it would be AND. Here it wants us to print hello if A is equal to B or if C is equal to D. So only one of them needs to be true, so we can put OR. This example misses indentations to be correct. Insert the missing indentation to make the code correct. We can put a few spaces. Use the correct shorthand syntax to put the following statement on one line. I think it's just like this. Use the correct shorthand syntax to write the following conditional expression in one line. And then it's for loops. A for loop is used for iterating over a sequence, that is either a list, a tuple, a dictionary, a set, or a string. This is less like the for keyword in other programming languages and works more like an iterator method as found in other object-oriented programming languages. With the for loop, we can execute a set of statements, once for each item in a list, tuple, set, etc. We already used this for loop in our first code over here. We used for character in character string, so it loops around the string starting with W and then E and then space. So it is the same thing over here. It loops around the list, fruits. So for each item in fruits, print the item. So it will first be apple and then banana, then cherry. The for loop does not require an indexing variable to set beforehand. So you can just do this without setting any variables. So you don't have to use a range or anything. Looping through a string. Even strings are iterable objects. They contain a sequence of characters. Loop through the letters in the word banana. So it'll first be B and then A and then N, A, and A. With the break statement, we can stop the loop before it has looped through all the items. For x in fruits, print x. If x equals banana, then break. So it will first print apple and then print banana, but it sees that banana equals to banana, so it breaks the loop and cherry will not be printed. Exit the loop when x is banana, but this time the break comes before the print. So it first sees if it's banana. If it is, then it breaks it. Otherwise, the x, which is each item in the list, will still be printed. Here, the apple will be printed, but banana won't be printed because the loop will break as soon as the x is equal to banana. With the continue statement, we can stop the current iteration of the loop and continue with the next. Here, for x in fruits, if x is equal to banana, then continue and print x. So when x is apple, it will print apple. If when x is banana, it will skip the banana loop. So this will be skipped, and then it will go to cherry, which will be printed. So in the end, only apple and cherry will be printed. The range function. To loop through a set of code a specified number of times, we can use the range function. The range function returns a sequence of numbers, starting from 0 by default and increments by 1 by default, and ends at a specified number. For example, for x in range 6, print x. It will start from 0, so the first time x will be 0, the second time x will be 2, and then, x will be 1, the third time x will be 2, the fourth time x will be 3, all the way to the sixth time x will be 5, and then the number 6 will not be printed. So it will print from 0 to 5. Note that range 6 is not the values of 0 to 6, but the values of 0 to 5. So it has 6 values starting from 0. The range function defaults to 0 as a starting value. However, it is possible to specify the starting value by adding a parameter, such as range 2, 6, which means value from 2 to 6 but not including 6. So here it will print 2, 3, 4, 5. The range function defaults to increment the sequence by 1. However, it is possible to specify the increment value by adding a third parameter. Here it will skip by 3, starting from 2. So it will be 2, and then 5, and then 8, and then 11, all the way to 30, but not including 30. So it will end at 29. Else in for loop. The else keyword in a for loop specifies a block of code to be executed when the loop is finished. Print all numbers from 0 to 5 and print a message when the loop has ended. So here it prints 0 to 5, and after the loop ends, it will print finally finished. The else block will not be executed if the loop is stopped by a break statement. Here, when the x equals 3, then the loop will be broken and everything here will be ignored. So it will print 0, 1, 2, and 3 will not be printed, 4 and 5 will all not be printed, and the finally finished will also not be printed. So it's just 0, 1, 2. Nested loops. A nested loop is a loop inside a loop. The inner loop will be executed one time for each iteration of the outer loop. Here it's printing each adjective for every fruit. So it first loops the adjectives starting from red, and then it loops the fruits starting from apple. It prints adjective and then fruit. So it will start with red and then loop through y. So it will print red apple, and then red banana, and then red cherry. And then the first loop for the adjective will be finished, and it will go to big. And then it will be big apple, big banana, big cherry, and then tasty apple, tasty banana, and tasty cherry. For loops cannot be empty, but if you for some reason have a for loop with no content, put in the pass statement to avoid getting an error. We also put a pass statement for the if statement if we want it to be empty too. So if we want a for loop to be empty without causing an error, then we also put pass. Loop through the items in the fruits list. So for x in fruits, print x. In the loop, when the item value is banana, jump directly to the next item. This would be continue. Use the range function to loop through a code a set of 6 times. A code set of 6 times. So range 6. Exit the loop when x is banana. So if we want to exit the loop, then it would be break. Last one, functions. A function is a block of code which only runs when it is called. You can pass data known as parameters into a function. A function can return data as a result. When you want to create a function, it is defined using the def keyword. So here you define a function called myFunction, and you put a colon, and you also indent here to show that this is part of the function that you're defining. So in this function, it would print hello from a function. Calling a function. To call a function, use the function name followed by parentheses. So here we defined it, but nothing happens if we just define it. If we want to call on it, then we put the function and the parentheses to run all the code inside of the defined function. So here, when we call on it, it will print hello from a function. Information can be passed into functions as arguments. Arguments are specified after the function name inside the parentheses. You can add as many arguments as you want to separate them with a comma. The following example has a function with one argument fname. When the function is called, we pass along a first name which is used inside the function to print the full name. So here we define the function and the argument is called fname. When the function is called on, it will print fname, which is the argument we receive over here, and then refsness. So here we called on the function with the argument Emil. So Emil goes into fname, so it will print Emil refsness. For this one, it will print Tobias refsness, and this one will print Linus refsness. Arguments are often shortened to args in Python documentations. Parameters or arguments. The term parameter and argument can be used for the same thing, information that are passed into a function. From a function's perspective, a parameter is the variable listed inside the parentheses in the function definition. An argument is the value that is sent into the function when it is called. So in the example, this would be an argument, but this would be a parameter. So fname is the parameter and Emil is the value we're giving to the parameter, which is the argument. Number of arguments. By default, a function must be called with the correct number of arguments, meaning that if your function expects 2 arguments, you have to call the function with 2 arguments, not more and not less. Here the function has 2 arguments, fname and lname. So when you give the function 2 arguments, it will be able to run it. So the fname will be Emil, lname will be refsness, so it will print Emil space refsness. When you try to call the function with 1 or 3 arguments, you will get an error. So you only give it 1 argument. It doesn't know what to do with lname, so it will have an error. Arbitrary arguments. If you do not know how many arguments that will be passed into your function, add a star before the parameter name in the function definition. This way the function will receive a tuple of arguments and can access the items accordingly. If the number of arguments is unknown, add a star before the parameter name. So we define a function with a parameter called kids, but we don't know how many values of kids we will get, so we put a star in front of it. Here we get 3 values for kids, and then we can print the youngest child and then plus, and also print the second one in the tuple of lists, the tuple of kids. So the second one would be Linus, because Emil is 0, Tobias is 1, and Linus is 2. Here, when the function is called on, it will print the youngest child is Linus. Arbitrary arguments are often shortened to star args in Python documentations. Keyword arguments. You can also send arguments with the key equals value syntax. This way the order of arguments does not matter. Here you define a function and the parameters are child 3, child 2, and child 1. You can print the youngest child is, and then child 3. When you call the function, you don't have to put the children's names in a specific order, and you can assign it to the parameters. Here you assign Emil to child 1, so this one, Tobias to child 2, and Linus to child 3. So when we print the youngest child is plus child 3, it will print the youngest child is Linus. The phrase keyword arguments are often shortened to kwargs in Python documentation. Arbitrary keyword arguments. If you do not know how many keyword arguments that will be passed into your function, add 2 asterisks before the parameter name in the function definition. This way the function will receive a dictionary of arguments and can access the items accordingly. So we didn't learn about dictionaries, so you guys don't need to worry about this. Default parameter value. The following example shows how to use a default parameter value. If we call the function without argument, it uses the default value. So we define a function and the default value is Norway, and then it prints I am from and then the country name. So when you give it an argument, the country will be the argument, but if you leave it empty like this one, the country will be Norway. So the first one will print I'm from Sweden, the second one will be I'm from India, the third one will be I'm from Norway, and the fourth one will be I am from Brazil. Passing a list as an argument. You can send any data types of argument into a function, string, number, list, dictionary, etc., and it will be treated as the same data type inside the function. Example, if you send a list as an argument, it will still be a list when it reaches the function. So here it defined a function called my function, and the parameter is food. For x in food, print x. So we have a list here with apple, banana, and cherry in it. And then when we call on the function, we use fruits as the argument. So this list will be given to food, and then the loop will loop through the list and print apple, banana, and cherry. Return values. To let a function return a value, use the return statement. So we define a function and it returns 5 times x. Here it would be 5 times 3, and then 5 times 5, and then this one would be 5 times 9. The pass statement. The function definitions cannot be empty, but if you for some reason have a function definition with no content, put in the pass statement to avoid getting an error. So we also put a pass statement for the for loops and if statements when we want them to be empty. So if you want something to be empty but don't get an error, just put pass. It doesn't do anything. And then there's also recursion, which is basically using the function inside the definition of the function. This can make the function more elegant looking, but it will also make it more complicated, and we won't need to use it anytime soon. So we can skip this part. Now we will look at the new program. So first, at the bottom over here, it is basically the same thing as the other program we did last week. We have a string and a character string, which is the message we're gonna encrypt. But for here, the offset is 2601, which is obviously really big. That's why we created a function so that it won't go off into somewhere else, and instead of printing letters, print some other stuff. So when we encrypt it, we're going to use the function that we define. So we define a function called char convert, and the parameters are char and n. N is the offset here, which is 2601. And then we make n equal to the modulus of n and 26. So 2001 divided by 26, and we want the remainder of that. So over here, n would just be 1. And then we continue to an if statement. If the character is in between capital A and capital Z, then we will run this if else statement. If the character's code point plus 1 is bigger than the code point of capital letter Z, so we know that the character set of A to Z would be like A, B, ... X, Y, Z. So if the code point of the character passes z, let's say it passes it once to this character, then we would minus 26 from it and put it back to A. That way it will stay in the capital letter set. But for else, so if it already stays in the capital letter set, then we just add n to it, add 1 to it, and it stays like that. And then elif, if the character is in between lowercase a and lowercase z, then we see if the code point plus n passes lowercase letter z. So a, b, dot dot dot, x, y, z. If it passes it, then we minus 26 again. So if it passes it once, we would bring it back to A. Else, if it doesn't pass it, then we just plus n. And then else, so this else is in line with this if and this elif. So it means if it's not within the capital letter A to Z or lowercase letters A to Z, then it's just new character equals character. So the character doesn't get changed. In the character string, the characters that would trigger this else statement would be all of the spaces and all of the non-letters, so like the dashes. So basically the spaces and other special symbols will not be encrypted. Only the characters will be encrypted. And then afterwards, after the character comes into the if elif else, the function will return new character. So the new character is either just the character if it's a space or a special character, or this one, this one, this one, or this one. These are all of the possibilities of the encrypted characters. So the encrypted character will be returned when we run the function. So here in the loop, for character in character string, it starts with capital letter W. The capital letter W goes into, because it's ch, it goes into the function as the character, and then it's in between capital A and Z. So it runs this if statement, but it doesn't pass capital Z when we encrypt it by 1. So it does new character equals character or char plus n, so plus 1. So W will be moved once to the right, which is x. So here it will return x, and then move on to lowercase letter e, which will also go through this and return encrypted character. And then that encrypted character will be added on to the encrypted character of W and added into new string. So new string will be keep on having more characters added onto it. After this for loop is finished, we will print character string, which is the original plaintext, and the new string, which is the ciphertext. And then the encryption will be done. Let's look at the code in Python. I copy pasted it over here and we can run it. So the plaintext is we are in room 222. The offset is 2601. Let's see what the ciphertext would be. It would be this message. So W turned into X, E turned into F, spaces remain the same, and the dashes remain the same. We can also change the message or the offset and play around with it. But this is how we can encrypt messages with a bigger offset. We can compare the two different codes. So here, this was the code from last week, and we basically copied it over here, except during the encryption process, we used a function to do it. This can make the running part of the code more simple. And another good part about functions is that if you're creating a code, you can usually, if it's a pretty complicated function, you can usually find it online because a lot of other people are using Python and they have written their own functions to do certain stuff in the code. So it can also save you a lot of time by borrowing someone else's function and using it in your code. This week's activity is to use the new code, change the message, and find the ciphertexts for texts when the offset is 2601, 261, and 27. Also, you can go into W3 Schools to review all the stuff that we learned and do the exercises, and you can also preview more content if you'd like. Make sure you also understand the code too. If you have any questions, you can ask me about it in Teams. After you're done, you can post your code into the program number 4 channel. Thank you.